Okay, so we're going to explain the purpose of blocking here and describe a randomized block design or a matched pairs design, which we've actually already done a matched pairs design. Because a matched pairs design is when you pair an experimental unit with another experimental unit that is very similar. And actually, the best way to do a matched pairs design is to pair a subject with themselves. And we did that when we tested your standing heart rate versus your sitting heart rate. You did both treatments. You stood up and took your heart rate, and you sat down and took your heart rate to see which one was different. That was a matched pairs design. But let's talk about blocking. Okay. Blocking is when you organize and group experimental units according to properties of that or what's a better word than properties? I think what is a better word? Maybe according to traits the individuals have in common. Okay, and I always use this very easy one, race or gender. Those are both ways we could block. We could block by race. We could African Americans, because sometimes there are times where people of different races react to medicines differently. So that's a common one. We block by something they have in common. Okay, you're going to see one in a minute when it comes to popcorn. I'm going to show you how we're blocking. All right, randomized block design. Okay, a pretty simple idea. The random assignment of experimental units to treatments is carried out separately within each block. Okay? So, for example, if we have a cancer drug that we want to test, we might want to see if there are differences between the way different races react to the drug. So we would have, our first treatment would be the drug itself, and our second treatment would be a placebo to make sure we control and to see if the drug has more of an effect than the placebo. And then we would block participants by their race, and we would randomly choose people within each race to get the treatment or get the placebo. That would be a randomized block design. All right, let's look at an example here. Microwave popcorn. A popcorn lover wants to know if it is better to use the popcorn button on a microwave or use the amount of time recommended on the bag of the popcorn. So those are going to be our two treatments. To measure how well each method works, she will count the number of unpopped kernels remaining after popping. So that's how we're going to compare. To obtain the experimental units, she goes to the store and buys 10 bags each of 4 different varieties of microwave popcorn: butter, cheese, natural, and kettle corn, for a total of 40 bags. A. Explain why a randomized block design might be preferable to a completely randomized design for this experiment. Okay, well, our solution to that: a randomized block design might be better because there may be differences within the varieties of popcorn already that would confound our variable of popping method. Okay? So completely randomized design would not take that into account, but a randomized block design would. Okay? While we can't control the variable of the of the different varieties, there are different varieties whether we like it or not. They're there. We can't control it, but we can block for it. So while we're not controlling it, we're accounting for the variable. And so again, we always want to keep the variables as much the same and account for the variables in any way we can, so that our one variable is the only thing that could account for the variation. Okay? Because there may be variation in unpopped kernels between the different varieties a completely randomized design may end up with confounded results. Since we can't control the varieties, we block to compare differences. I should say we. Okay. So B, outline a randomized block design for this experiment. Describe how you would carry out a random assignment required by your design. Well, if we're going to do a randomized block design for this experiment, we would, within each group, we have to state that we're going to do it within each block. We should say block and not group. Within each block, okay, number the bags from 1 to 10. Put the numbers (1 to 10) on equal sized pieces of paper. Throw in a hat and mix well. Draw 5. These 5 will be popped using the popcorn button. The rest with the recommended time on the bag. Pop the 40 bags in random order. So you'd randomly choose which one goes first, second, third. Okay. Count the number of unpopped kernels in each bag and compare within each block. Then compare the treatments for all all 40 bags, taking the varieties into account. That would be a completely randomized design, or sorry, a randomized block design that would allow us to see if the variable of popping method did make a difference. Okay. The last thing we have here is matched pair, which we've already said. Matched pair is create blocks of similar experimental units, and then use chance to determine which unit gets which treatment. Okay. Now by doing that, most of the time, pairing a subject with itself, a unit with itself, is preferable. So we talked about the one where we did the standing heart rate, but also if you wanted to test something like razors, you wanted to test which razor did a better job of shaving, you could pair a man with himself, and then you would randomly select which side of his face is going to get shaved with one razor and the other side would get shaved with the other. So you would have to randomly select, but that would be a matched pair with himself. And you want to make sure you randomly selected which side, because if you have a dominant hand, which everybody has a dominant hand, then you might shave differently on the dominant hand side than you do on the non-dominant hand side. And so you'd want to control that variable by randomly selecting which side they shave with which razor.